key distribution and management, right? So we started discussing about this interesting topic, key distribution and management. We understand the importance of key distribution and management both for symmetric and asymmetric. For in the both cases, what is the importance we have discussed. Also, we discussed the the key hierarchy, right? Especially in the case of a symmetric environment, the role of key hierarchy in the sense you have the master key, you have the session key, right? So we understand that session keys are used typically for the purpose of data exchange, right? So during the session, whatever the communication that is happening, that would be encrypted with the help of session key. Now the issue is, how do you have the session key? So take the help of master key and use it for session key exchange, right? So in the yesterday's class, we have seen a typical key distribution scenario, right? So we understood how the role of key distribution center is playing a vital role in establishing the key between the two nodes. So while discussing that, we also noted, though we have key distribution center, but the point is that it is not a foolproof mechanism, right? So you can look at the diagram that is given there on the slide. You can notice there is a key distribution center, right? Now A wants to talk to B. For that purpose, you can notice the A is initiating the interaction with the KDC, asking, look, I need a session key so that I want to talk to B. Okay, so yesterday class we have seen a key distribution scenario where the A and B are interacting. A and B are trying to interact, and for that A is establishing the contact with the KDC that we have discussed. Now let us extend that interaction little more further. If you notice, when A is trying to talk to B in this particular scenario, there are two things. One is the identifier of A and identifier of B. That means the source of the message and destination of the message A is mentioning. In addition to that, there is a number called N1. Okay, so N1, similarly, you can notice somewhere N2. So the N1 and N2 are typically random numbers, also called as nonces. Random nonces. Okay, not nonsense or something, nonces. We will see what is its role little later. Now A is asking, in the previous yesterday's class, we don't have this N1. Now N1 is added. If you guys remember, yesterday we have discussed only this particular part. Now KDC is responding to this particular request from A with an encrypted piece of communication. Now if you notice, the encrypted piece of communication yesterday we discussed like in the form of a box, and within that box there was another box. So the same philosophy here also, except the point is that you have that N1 added. So the N1 that A has sent, N1 was there here. Okay, and now the symbol this is given here is concatenation symbol. So if you notice here, IDA and IDB and the nonce. Now for that, the KDC is responding back by encrypting the message with the help of master key. Master key between. Can somebody tell me what is the master key between? This is the master key between. The entire whole piece of communication is encrypted with the help of master key between?
Sir, KDC and A, sir.
That's all. So because if you notice the communication is happening between the KDC and A, obviously that particular communication is encrypted with the help of master key between KDC and A. That is what is KA. What is there inside the communication? The session key that both A and B should use. Similarly, the rest of the message is the message what actually A has sent. Now, in addition to that, there is one more encrypted piece. Now, this encrypted piece is encrypted with the help of master key between KDC and B. Now, A gets this by decrypting this entire message with the help of the master key between A and KDC. But A gets this part and gets the KS. A gets this part also, but he cannot do anything because it is encrypted with the help of KDC and B. So that same point he would transfer it to B. So this particular box. Now this particular box can be decrypted, or this particular piece of message can be decrypted by B alone because it is encrypted with the help of KB, which is the master key between the KDC and B. Now B takes this. Once B takes, B gets KS. Right. So now A is already having KS. B also got KS. Now the session key is established. Now if you notice, there is a fourth step. The fourth step is what B did. B took that particular session key, whatever now B has received, encrypted a random number called N2, which is a random nonce, and he has sent it to A. Now A would decrypt this particular communication because KS is already with A. Now once A decrypts this fourth step, A gets N2. Okay. Now A responds with the fifth step by encrypting this N2. Of course, it is not simply N2, it is f of N2, some function over N2, some random function. It could be say square of the N2 or square root of N2, some arithmetic function over N2 he will perform, and that particular output he would encrypt with the help of session key and send it to B. Okay. So B receives it, B decrypts it, of course, because with the help of KS, and B gets f of N2. Now the point is up to 1 to 3. What is the purpose? 1 to 3 steps purpose is to establish KS. Now what is the purpose of 4 and 5? The purpose of 4 and 5 is to ensure to each other, both A and B, that look, I got KS. So if you notice, B has actually got KS by step 3. Now B is communicating with A by sending some cryptographic nonce or a random number, which is encrypted with the help of KS, and A is able to decrypt it. Now by decrypting this fourth step, A will understand that, oh, B got KS. So that means our KS is established. With B also, we can start communicating that A understood because of that fourth step. Now that understanding A has to communicate it with B. So for that we have the fifth step. It is a kind of a handshake saying that, okay, look, I got KS. That is the fourth step by B to A. Oh, you got the KS, that's good, very good. That is the fifth step. Okay, nothing else. There is no much significance to that function. The function can be anything. The function can be random, but only thing is that the function should have got understood by both A and B. Either I am performing square root, square, whatever it is. Okay, is that clear? The key distribution scenario. Hello.
Yes, sir.
So this is a slightly modified version than the previous class. Now the point is, yesterday itself we have understood. Now it is not that KDC will cater to the need of A and B alone. right? We have seen a diagram where KDC was sitting in between and you have n varieties of nodes and KDC is catering to the needs of all those nodes, right? So the point is, we also discussed yesterday that the KS is the session key. The point is, with the hierarchical key control, you have master key, you have the session key, right? So remember, when you have the KDC, the master key is generally existing between the nodes and KDC. Okay, so you have the KDC sitting here. Then you have the node A, node B, node C. They have master key with KDC. That's what yesterday we have seen, D, E, F. So every node is having the master key. Now A wants to talk to F. So A sends a message to KDC and KDC will create the session key and give it to A with the help of the master key between A and KDC. And similarly, master key between F and KDC, right? So that's what is the role of master key. Now the session key is for communication purpose. Okay. So now the point is how long the session key would exist. We said, look, you can have, it depends upon the kind of application. The application, may demand a longer duration session key. Application may demand a shorter duration session key. But the more, the point is the session key is valid only for the duration of the session. Okay. Now, it's not only that. We also said your network architecture, essentially the layered architecture in terms of, TCP/IP protocol stack, even that also plays a role. If you notice the TCP/IP protocol stack, you have certain connection-oriented protocols and you have connectionless protocols. Can somebody tell me what is this connection-oriented and connectionless? What do you mean by connection-oriented protocols and connectionless protocols? Hello?
No idea, sir.
No idea. Yeah, you are in the pre-final year. You must have completed computer networks, right? You guys completed computer networks?
Yes,
yeah.
I completed.
Yeah. What is connection-oriented protocol and what is connectionless protocol?
Basically, in connection-oriented, a dedicated made between the two persons that are talking, but in connectionless, there is no dedicated connection.
So without connection, how they will talk? If that is the definition.
No, there is no dedicated connection between. That means the channel that they will use to communicate is not just for those two. I can use that same channel to talk to other person C2.
No, see, that's what, internet, right? So internet is the open channel. Anybody can use, any people can communicate it. So does it mean that, it is internet uses only the connectionless protocol? Okay, so think on that and just check that. So it is like this. If you notice, you have connection-oriented protocols such as TCP, and you have, if you remember, UDP is the connectionless protocol. Okay, so the point about connection-oriented and connectionless protocol is this. You guys hope you remember that there is a concept called reliability. Which is reliable, connection-oriented or connectionless?
Oriented.
Why it is reliable?
Because
so
there
the
will
point
not be
is
any
so it is
interruption
like,
when those two are talking.
Yeah, no. So okay, so it is like this. Please, this is very important in the sense that not only for your networks but also for security point of view. It is like this. The connection-oriented protocol, what happens when A and, say, take an example, F, both are talking to each other. In connection-oriented protocol, for every communication that happens between A and F, imagine if A is telling that hello F, this is A. For that, there should be an acknowledgement back from the F saying that, yes, oh, you are A, I got your message, something like that. So the point is, for every hello request, there should be an acknowledgement. That means for every sync request, there is an acknowledgement. For every message that goes from one corner to the other side, there is a response, there is an acknowledgement. That's where your TCP protocols, which are connection oriented protocols, if you have that connection, sync and acknowledgement is there, then you call that protocol as the connection oriented protocol. Imagine you don't wait for acknowledgement. You just only send hello message. There is no need for response. That is connectionless protocol. Okay. So connectionless protocol, since there is no acknowledgement, do not guarantee you that whether your message of sync, whether your message of hello is reached by to the destination or not. Whereas the connection oriented will ensure you that because you are getting an acknowledgement, it gives you guarantee that yes, my message is done. This is about the networking point of view. Now, this plays a significant role in the your security. What is that? The point is A and F wanted to talk to each other. So using connection oriented protocol, because communication is somewhat sensitive or somewhat important. So for every message that goes between both of them, they need to ensure that the message was received. Now this functionality of connection orientedness brings a security vulnerability. What is that? Now imagine A wants to see that F should not talk to anyone else. Okay, so it is kind of a denial of service. Whatever the service that is offered at F, it is not served to anyone else. So for that purpose, what A would do? A would be keep sending the sync messages. For that, what F has to do? If it is a connection oriented protocol, if there is a request of sync message from A, what F has to do?
Send acknowledgement.
Send acknowledgement, because it is a connection oriented communication. So A would be keep sending sync messages, F would be responding back with acknowledgements. Is there any fruitful job that F is doing? Hello?
Yes, sir. He's making sure that he knows that the message was sent properly.
That is what, yeah, that's okay. That is the connection orientedness. My point is now A is the malicious user. A is keep sending sync messages. What F would be doing it? What F would be doing it for sync messages? F would be sending back the acknowledgements, right?
Yes, sir.
Yes.
So F would be busy in sending the acknowledgements. That's all. Imagine, F is your some sensitive server. Now A and B and C, they want to attack F. What ABC would do? A is from a different location, B is from a different location, C would be from a different location, but typically they are the attackers. What ABC would do? ABC would be keep sending request messages or sync messages to F. F would be responding back saying that okay, acknowledge. So they will be keep sending sync. The F will be responding back acknowledge. So F would be keep sending the acknowledgements. That's all, nothing else. Imagine if D is a legitimate user asking F to do some service, F would be in a position to meet the requirement of D. F is keep sending the acknowledgements to ABC. That is called denial of service attack. If ABC are from a different locations and from different look at this thing, it is distributed denial of service attack, because from multiple sources, F is being attacked. Are you able to follow?
Yes, sir.
So the problem with the connection oriented, the point is you introduce the connection orientedness because you need to ensure the reliability, but that is becoming a vulnerability, right? Of course, there are mechanisms that can withstand, that can mitigate this denial of service in this particular manner. But the point is, it is introduced the vulnerability. Now the point is, now you have connection oriented protocols and connectionless protocols. Now, what is the duration of my session? Duration of my session key. What should be my duration of my session key? That depends upon whether the protocol is a connection oriented protocol or it is a connectionless protocol. Remember, during a session, when there is a session, you can have multiple connections. Okay. Okay. So that means for a connection oriented protocol, same session key can be used for multiple connections as long as the session is there. And for a connectionless protocol, since it is a connectionless, every communication needs a new session key. Okay, every communication. That means from A to F, there is a communication, a session key is needed. F to A, there is a response back. Then there is a new session key needed. I hope you guys are able to follow what we are discussing. When there is a connection oriented protocol, you can use the session key for multiple connections. When there is a connectionless protocol, you need the new session key for every communication. Okay. Because there is no connection concept. So a message from A to F need a session key. A response from F to A needs a session key. And for that, if there is another communication from A to F, needs a new session key. Okay, is that clear? Hello, is that clear or not yet?
Yes, sir, that's clear.
Yes, sir.
Yeah, so that's what is important. We need to know whether the communication protocol that is used is a connection oriented protocol or a connectionless protocol. And also the other day we discussed the point about the the role of KDC and having a KDC, how it introduces another vulnerability, right? So that's what we discussed on the other day. So now let us see how this can be handled in a decentralized manner. You can notice I need not have a KDC. Instead, there is a decentralized distribution scheme for the session key or the symmetric key. Now, in this particular scenario, there is no KDC. Okay. Now, A wants to talk to B in a symmetric fashion. So A is sending a message to B saying that, hey, look, I am so and so. This is my identity. And this is my nonce. Some cryptographic number, some random number. Now B responds by creating. Earlier, you remember the role of create the session key was created by KDC. Now B is creating the session key. B creates the session key and sends that particular session key. Okay. Sends the particular session key with A. But how it is sending? It is sending in the form of an encrypted communication. Okay. When it is an encrypted communication, how it is encrypted? With the help of master key. What is the master key? The master key between A and B. Now, what was that inside that particular communication? The communication is the session key and the identifier of A that was sent by A earlier. Now B's identifier and the number that A has sent. For that, B performed some mathematical function F over N, N1. And in addition, B is sending its own nonce. Now A receives it. Will A be in a position to decrypt the second message, second step or not? Certainly yes, because though it is an encrypted piece of communication that was encrypted with the help of master key between A and B. So A also has that master key, so A will decrypt it. So A gets KS now, and A understands that, oh, this is the response for my first step. So in that way, by having this nonsense, you are going to mitigate the replay attacks. Okay. So if by decrypting this message, A will get the session key and A will get, oh, this is the IDA what I have sent in my first step, and there is f of n1, some function over n1, and the IDB, the identification and the nonce. Now A will respond back to B saying that, okay, look, I got the session key. How it is responding? By performing some arithmetic operation over N2 and encrypting the result with the help of the session key that was established with the second step. Now B receives it. B now decrypts it because that was encrypted with the help of session key. Already B has the session key. So B will get f of N2 and understand that, oh yes, I have sent N2, A performed that arithmetic operation and now I got f of N2. That means my session key that I have sent in the second step was received by A. Okay, this is called a decentralized key distribution scenario. You understand?
Yes, sir.
Now there is the advantage of this key decentralized scenario is that there is no need to have a key distribution center, and in that way you are able to manage the attacks, saying that, imagine KDC is down, KDC is up, somebody attacked KDC, kind of those things, and the delay between the communications from A to KDC or B to KDC or whatever it is. So those can be mitigated. But the point is, in the previous scenario you have seen the 5 steps. Now the communication steps are only 3. Okay. Is that clear?
Yes, sir.
Okay. So, and another thing is, remember here all this works if there is a master key that is already established. Remember, that is very, very important. All this works if there is a master key that was already established between A and B. Without having the master key between A and B, there is no way that the session key can be established. Okay. So that's the reason why the previous slide, if you notice, we said master key is meant to for the purpose of master key is meant for the purpose of session key exchange, and the session key is used for the purpose of data exchange. Okay. Similarly, you have different types of session keys. Remember. Okay. When you have different types of session keys, what kind of session keys you are using? Say, take an example. Your session key can be like a kind of the PIN number. The session key is for the purpose of encrypting the data. Okay, like that you can have, depending on the kind of application you have, you can have various types of session keys. Now, so far whatever we discussed is about sharing symmetric key. Okay, whatever so far we discussed is sharing symmetric key, or else it is also called as session key. Okay, so far what we discussed is sharing of symmetric key or session key with the help of master key. Is master key is a symmetric key or asymmetric key? Hello, master key
Correct.
is a, sorry.
So it's a symmetric key.
So it's a symmetric key. Master key is a symmetric key. That's why so far whatever we discussed is about sharing the symmetric key or session key using symmetric key. or master key. Okay. Whatever the techniques we discussed so far is about that. Is it that my session key can be established only with the session key, with the master key, and that means only with the help of symmetric keys? No, I can have my 1 minute. I can have what is the other key mechanic? Other keys you have? Asymmetric keys. I can use asymmetric keys. So how do I use asymmetric keys to share session keys? Asymmetric keys are public key to share your symmetric key, session key or symmetric key, right? How can I use this? You can see a simple scheme. What is the scheme? A and B wants to communicate with each other with the help of symmetric schemes. Okay, so A and B wants to communicate using symmetric. Now, for that purpose, they need the session key. So need session key. For that purpose, what A is doing? A is sending. Remember, this works if you have already public key and private key pair with both both ends. A is sending a message to B. What it is telling? Hey B, look, this is my public key and this is my identifier. For that, what B is responding? B is creating KS. Then sharing that KS by encrypting KS with the help of public key of A. Okay, A has sent public key, right? So B is encrypting this session key that B has created with the help of public key of A. Now A will be able to decrypt second step or not? Hello?
Yes, sir.
How it will decrypt? Decrypt step
All
2
it needs
with.
to decrypt is its own decryption key, that is private key, PRA. Because
That's
it
what you
was
tell me. How A will decrypt step 2? Decrypt step 2 with
PRA.
Private key, sir.
of.
Yeah. Of A.
Once B decrypts the this message, what A gets? Get
Session key.
Session key. Once A gets session key, from now onwards, A and B can communicate with each other in the case of with the help of symmetric key, right? So now if you can recall, few classes back, we said, what is the use of public key? What is the use of symmetric key? I hope you guys recall. Once we completed RSA algorithm, I asked you guys the complexity of RSA algorithm and the complexity of AES algorithm. Okay, we have noted the complexity of RSA is quite more because of the computational steps that are involved, right? And that's the reason why public key schemes are used for the purpose of sharing symmetric keys, not for encrypting the messages. Okay. Now, tell me, this is the way you are going to establish the session key. Now, tell me, is this fine enough? Do you see any problem in this scheme?
Authentication.
Exactly. What is that problem?
He has no idea who actually sent the KS, means if B was involved or if C was involved. He has no idea.
Here it is encrypted with the help of public key of A, correct?
Yeah.
So what kind of attack this will introduce? Yeah, authentication is the exact answer. What is the kind of attack it will introduce? It introduces man in.
Is it man in the middle?
Yes. So if you notice, the first step is sending public key of A and identifier of A to B. Now this is the first step. While sending the public key and identifier of A, Darth will capture the public key and private key of A, and Darth will send public key and identifier of Darth to Bob. Now Bob thinks this is the session key, creates the session key. Bob will encrypt the session key and send it to Darth. Darth will have the session key, and Darth will create a session key and send it to Alice. Now the point is that the session key is now established between Alice and Darth. Another session key is established between Bob and Darth. Right? So there is no authentication mechanism. Now, how do I bring in the authentication as well as confidentiality in this scheme? So can I achieve both? Of course, you can achieve both. We have discussed this concept of achieving authentication and confidentiality with the help of asymmetric key schemes. I hope if you guys can remember that when we talked about the fundamentals of asymmetric key schemes, we talked about how we can achieve both confidentiality and authentication, right? So there is no authentication. Okay. So how to achieve confidentiality and authentication? We have discussed this while talking about introducing the public key scheme. Now you notice this particular scheme. This is aimed at achieving confidentiality and authentication. Look at the first step. It is first thing is it is an encrypted communication, right? So A has used public key of B to encrypt the message, and the message contains the nonce and identifier of A. B receives this message, decrypts it with the help of private key of B, and get N1 and identifier of A. Right? Now B is responding back saying that an encrypted communication with the help of public key of A and the N1 what A has sent, nonce of A, and B introduced nonce of B, another nonce. Now A is sending another encrypted piece of communication by encrypting the nonce of B with the help of public key of B. B receives this communication and understands that N2 was received by A. Okay. Now A is creating a session key. Session key was created and A encrypted that particular session key with the help of private key of A. Okay, so A has encrypted with the help of private key of the sender, that means A, the session key. Now that encrypted piece is again encrypted with the help of public key of B. right? So since B receives this message and first it is encrypted with the help of public key of B, now B will decrypt it with its private key and gets this particular piece of communication. Now this particular encrypted piece of communication is encrypted with the help of private key of A. That means it has to be decrypted with the help of public key of A. So B uses the public key of A and decrypts the message. Once this decrypts the message, B gets session key. Right? Hello?
Yes, sir.
Hope you are able to follow the scheme.
Yes, sir.
Okay. Now, but the point is, if you notice very clearly, there is one important thing. In the first step, how A knows that the PUB is the public key of B. Okay. In the second step, how B knows the PUA is the public key of A.
Aren't the public keys broadcasted through the complete network?
So that's what we need to discuss. What is the way of distribution of public keys? Okay. So what we discussed is here we are able to establish the session key with the help of public key schemes. Okay. And we are able to achieve both confidentiality because you can notice that it is encrypted with the help of public key of the receiver and only receiver can decrypt. So confidentiality is achieved. Now the session key was sent by A. How it is you are ensuring it? You are able to decrypt it with the help of public key of A. And because of that, you are able to say that yes, session key was sent by A. This is the authentication. But the fundamental question is, before this happens, how both nodes actually know what is the public key? Because I'm using public key, right? First step I have the public key and in the second step I have the public key of A. First step I have the public key of B. How both nodes know about it? So that problem is called distribution of public keys. How this happens? This we would be discussing it in the next class. So you can take it that you have up to this particular point. That means it is chapter number 14 up to chapter point number 14.2. You have for your CAT syllabus. Okay.
What type of questions should we be prepared for?
It is 10 marks questions. So as I keep telling, please have a look at the book back exercises of William Stallings and the kind of if you notice our sessions, the sessions whatever we discussed. Of course, if it is coming to the